Afternoon, everyone. We are going to start now. My name is Amit Joshi, and I am the Structural Engineering Institute Los Angeles Chapter's chair. Today, we are here for a presentation along with the American Society of Civil Engineer Metropolitan Los Angeles branch. We recently started the SEI chapter here in Los Angeles, and this is our second presentation in our series of presentations. So I would like to introduce to our speaker, Mr. Doug Fredericks. He's a structures leader at SOMAS, and he is going to be delivering today's presentation on red car multi-use bridge over the Los Angeles River. A little bit about Doug. He has been the structures leader at SOMAS for the last 6 years. Before that, he was a senior transportation engineer at CH2M Hill. He has worked on several complex bridge replacement, bridge widening, and rehabilitation projects in his career. He has a Master of Science degree from UC Davis, and he has a bachelor's degree from Cal State Chico. He is the lead engineer on the red car multi-use bridge, which is over the Los Angeles River. I would like to hand over to Doug.
Hey, thanks, Amit. Appreciate it. I'm gonna
Thank you, Doug.
switch over here to my PowerPoint, and
Yeah, you can start sharing.
And we'll get this thing rolling here. Okay. Yeah, thanks, Amit. Thanks, Kevin. Appreciate the opportunity to give you guys this talk about this project. It was just a very cool project. It was a fun project to do. It was one of those things where it really met all the goals that we set out for the project early on, and it's one of these projects that the community really likes. You know, the client likes the output, the outcome. You know, we enjoyed working on the project. It's kind of a feel-good project for all. So what it is, it's the red car multi-use bridge over the Los Angeles River. And here's a picture of it on opening day, and you can see it's a simple steel truss bridge over the river. It's sitting on top of these piers, which we'll talk about later on as we go through. Ended up being a very simple superstructure design for the bridge itself, and maybe a little complicated on the substructure design. And it has a lot of very cool features of aesthetics, like this lighting that we put on, and some nice aesthetic touches on it as well. So, anyway, great project, and looking forward to sharing it with you guys today. So this is the project team, and I wanted to just give a shout out to the city staff that was great to work with through the whole process here. Andrew Asfor at the city led the construction effort, which happened basically on time and went really well, despite the fact that we had a lot of rain, which you'll see in the photos that come up. Wen Chin has been involved in the greater project for a long time, and Wen provided a lot of good leadership to us as we worked through this project. And then, of course, Shirley Lau, the big boss, who was great to work with as well, really helped with the visioning of the project and that sort of thing. So, and then you can see the various other teammates here in this picture. This was taken on the kickoff day back about a year ago. So, also, just wanted to mention Craig BG. Craig was really key to the aesthetic enhancements on the bridge itself, and I think, as you'll see, did some really great work to take the bridge and turn it into something really special. And then we've got the other teammates that were involved in the project: earth mechanics, our own surveyors, JRP Historical Consulting, and then our traffic people and our environmental people. We did the structural design, we did the civil design, we did the environmental permitting. So big project, lots of moving pieces. So where is this thing? So you can see on this slide, here we are at this is Interstate 5. This is north of downtown. The Hyperion Avenue and Glendale roads meet just over I-5, and then they cross the river together. And this bunch of bridges here, we call the Glendale Hyperion complex of bridges, because it's really complex. There's a bunch of bridges here. It's about 5 separate bridges. These were built in the 1920s. I think if you're in the Los Angeles area, you know about these bridges. You've seen them, you've driven over them many times and under them many times. Very cool design from turn of the century. Really cool Gothic architecture, interesting aesthetics and pylons and great stuff. But because of its age and the type of bridge it is, not great for seismic issues. So SOMAS is leading the retrofit of all of these bridges here at the complex of bridges. And that's one of the reasons we have the pedestrian bridge, which is located right here in the yellow, I think you can see. And this bridge runs along the alignment, this yellow bridge here where we put the pedestrian bridge, runs along the alignment of the historic Pacific Electric red car trolley that used to run throughout LA in a bunch of different places. This was the red car line, which ran north up into to Glendale. So just can't really talk about this bridge without talking a little bit about the history of the red car, the Pacific Electric train system. And here is a picture of it going over Fletcher Drive nearby. This picture was taken like 1952 or so. So the red car trolleys were essentially a private transportation system constructed by Southern Pacific, which owned a bunch of property outside of downtown LA. And they needed to get people to like the idea of leaving downtown LA to go buy houses where Southern Pacific owned property. So they ran the red car trolleys in the Pacific Electric system essentially as a lost leader to get people to move out of the downtown area. This is back, 120 years ago when, Glendale was a long ways away from downtown, right? So the Southern Pacific system was really set up to just get people out to the outer parts away from downtown where they could sell them houses. So this picture was taken in 1952. The system had sort of, ridership was dropping. People were switching over to cars. We were becoming more of a car culture at that time, of course. And so the Pacific Electric trolleys sort of went by the wayside. But from a structural engineering, since this is the SEI group, you can look at this, and this is obviously not something that was, cheaply built for just simple electric trolleys. This is a fully ballasted system. It's got concrete deck. This is a very deep steel girder going across here, and you'll see that when we get to our site, the same kinds of details there as well. So here's the Pacific Electric train as it crosses over the LA River. And so what you'll see here is we've got the piers in the river. These are the same piers that we either cut down to get our new bridge through, or we reconstructed in order to support our new bridge. But our new bridge runs right along this existing historic Pacific Electric red car trolley line. So most of the structural, or say the aesthetics of the superstructure really were derived from this train system that went through here on this site. So, and so you can see these are massive piers. The footings are exposed above the LA River channel. And this was built before the LA River channel actually went through. So I'll show you pictures of that too as we go through. And again, just another picture of the trolley. This is a good picture because I've got a later one that shows what happened after they removed all of these pieces. So all the power lines came down and they took away the superstructure, and they just left the piers sitting there, and they sat there with nothing happened to them since 1958 until last year, basically. So about the bridge superstructure, the concept of the aesthetics of the superstructure. I'll talk about the superstructure first, then I'll move into the substructure issues. But the guiding principle of the bridge really was that it should be simple, elegant, economical, and that it gives a nod back to that red car system that went by. And so these are all slides. These were prepared by Gruen Associates and Craig over there. So I just copied him, but I'll make sure that full credit goes to Gruen Associates for these slides that I'm about to show you here. These were renderings created and given to public meetings to show the people, mostly the folks out at Outwater Village who are right next to the bridge here, what kind of structure that they were going to get and what the aesthetics of it were going to look like. And so Gruen was able to come up with a couple of different options and thoughts for how the bridge would look, and we used these during public meetings to communicate to people what we were planning to do, and they were able to then respond back to us with changes. And we did change things based on public input. So it was a very open, very good public process with the neighbors. And you can see the idea here. It's you know, again, it's a simple truss bridge. It's open, doesn't have a cover, no roof that runs along. The idea is to let people see the natural surroundings, let people interact with the river. You'll notice the red railing that runs along, and the idea of the red railing really is just to sort of harken back to that red car trolley that ran along the alignment. So those types of simple, just really neat aesthetic things really came through on the final result of the project. So again, these are just some renderings to go through. And here's a picture of the bridge, a rendering of the bridge from the Caltrans off-ramp nearby. So, and one of the things that we looked at originally, we weren't able to do, but there was a concept to put in the middle, a little shade structure in the middle of the bridge, and we weren't able to make that happen, unfortunately. But the idea of the shade structure was that it was going to sort of represent the trolley going across the bridge, and kind of looks like it's in motion as it goes across. And I thought that was a really cool concept, but unfortunately we weren't able to pull that one off. So, so that's the superstructure design. And you can see here, this was a video from opening day. And I think it's probably playing for most people. I'm just going to let this roll here. I'm sure there's some slower internet connections maybe that need some time, but you can see, you know, simple bridge, simple truss. It's going right over the top of the existing piers in the river. And there's the LA River underneath. And I'm going to let this play for a little bit and then point out some of the details here and let it catch up with people. Very nice opening ceremonies that the city put on. It was a good day. Okay, so I'm pausing it there. Again, so some of the details I wanted to point out as we're going to move into the kind of the substructure design of this thing. So obviously we've got the channelized LA River, which is maintained and operated by the Army Corps of Engineers. LA County Flood is involved. We're cutting underneath some LA DWP power lines out here. So, you know, we've got a lot of different agencies involved and had a lot of different agencies involved in a lot of the project, and, you know, a lot of sort of complexity in terms of putting a new bridge on top of existing facilities. But if you look here, we got the channel and the river. These are all original piers that were built to support the red car trolley back in the 1920s. We actually had to cut them down because they went up a lot higher than this, but we wanted to be closer down to the river, and of course we needed to meet ADA and all that sort of thing. So we actually went out there and just sawed off the tops of these existing piers. You can see, I guess on this one's probably the best way to see that. So we were not using this pier as a support, so we had to just cut it down and make sure we could fly over the top of it. So we sort of hopscotched into some of these piers. But this one, for instance, two of them, this one and this pier, we actually did support on piers in the river. As you can guess, these were old piers, so we had to rebuild them in order to do that. And I've got some pictures of that coming up as well. So let's see, I think I'll let this play out here. But you'll notice the bridge is silver colored in order to match the existing concrete. We really wanted it to just sort of blend in with its surroundings. And the only thing we really wanted to pop out was the lighting, which you'll see later. And also just that red ribbon of steel going across to represent the red car trolley. Turned out really well. And let's see here, okay. Yeah, so I guess from the structural standpoint, I think the real interest is in the substructure design of the bridge. How do you support a new bridge on top of piers that were built in the 1920s, right? So we had our work cut out for us here. This was really the best picture I could find, and I know this isn't a real high res here, so I apologize. But this picture shows both the Glendale Hyperion Bridge, which is of course in place today, which we are retrofitting, and it shows the red car bridge, and it shows those piers sticking up. But what you'll notice is different here is that this is a natural channel. So this picture was taken actually before the channelization of the river went through and basically put in a U-shaped channel through here and made this all concrete. So what you see at this very last pier, when we first went to the site, we just thought that was an abutment, but it's really not an abutment. It's actually just looks like an abutment because it ended up getting buried back in like 1930, when they channelized the river, and these things were just kind of buried forever until we came along to put our new bridge on top. And here is those piers that we had to deal with. You can see there, I'm not sure this comes through on the photo that you guys can see, but you can still see literally the anchor bolts sitting here for when they just took off the superstructure. They just left the anchor bolts, cut off some of them, and took their superstructure and sold it for scrap or whatever they did, and just left everything sitting there for some 50 years or so. So we had to figure out what we had on our hands. Now, there's no as-built available for any of this stuff. I'll show you some snippets later of some hints we had of what this thing was made out of and what was inside of it. We literally didn't even know if these things were solid or hollow or what we had. No as-built, nothing. So we had to do a lot of investigation to figure out what we had on our hands. And of course, the first thing you do is send out a survey crew. So at SOMAS, we've got really cool technologies. This is a Lidar point cloud scan that we did of all of the bridges out there. And it ended up being a great thing to have because we're able to look back at this point cloud and get all of the geometry of the site that's important to us. This snippet here shows this would be the Glendale, North Glendale Bridge, shows one of the pylons that's sticking up here. So we've used this for a number of things, one of which is to figure out where those big power lines I showed earlier, how close those are to the construction. So you can see the power lines here. And again, this is great. This is just point cloud data. So each one of these little things we're able to essentially click on, get an XYZ coordinate of right down to the leaves on the trees over there. So it's really something. I get a little motion sickness when I watch this, so hopefully no one else does either. so let this play out. And so lots of interesting things. The retrofit of the Glendale bridges. You'll have to have me back for just to talk about that. You can see here's the power lines up above flying over on this point cloud. So we did the usual site surveying, figured out where everything is. The other thing, again, we didn't have any information on these piers. So we just started cutting holes in them, literally, to figure out what we had. We didn't know if they were hollow. We didn't know if they had a rebar. We didn't know anything about them. So we did a destructive testing program on the piers where we just went out basically and took a bunch of cores of these things. And so here's the guy, you know, literally just putting a 12-inch core right through the middle of this thing. And we wanted to just see what we'd find out. So as they pulled out cores, we were able to look at each of them. And, you know, I don't think the resolution is quite good enough for you always to see this. But basically, you know, what we had here was really good concrete paste. We had good aggregate distribution. You know, we had some sort of face cracking that you would expect to see here. But the thing you don't see is rebar. Because there isn't any rebar, turns out. so we had these tall piers, and there was no rebar in them. So doing a little research on this, turned out that that's apparently wasn't unusual in the rail bridge world to have unreinforced concrete piers until pretty late, like the 1940s. And then this, because this was built in the 20s, this was in this period where they literally thought of concrete. I think there's some places they even call it like fluid rock, basically. They just thought of it as, hey, we used to do all these rock abutments. You know, why don't we just pour concrete out there? It's kind of like rock. So they didn't really worry about rebar, which was fine for them, but not great for us. So after we learned that, we kind of had to go back to the drawing board and figure out what to do here. So we'll let that. Play through. So, oh, I guess it's going again here. So I think it's just more pictures of the cores that went through. We put the cores in strategic places so that we, you know, if there was going to be rebar, we knew we would hit it, and if there was going to be cells, open cells in the piers, we knew we were going to hit it. We thought actually it would be hollow. The Glendale bridges just next to this, those are piers, and they do have voids in them, and they are hollow. But these old railroad guys, not so much. So just massive concrete. Okay, so once we had figured out what we had to deal with, we started looking at options for spanning the river. And here you can see this is a SketchUp model we put together of the existing facilities and where the white being the new stuff we might do. The existing piers are shown here. These connecting walls, these were put in way back in order to train the river as it runs through here so that the red car bridge piers wouldn't see any hydrostatic forces on them. All of the nosings and everything are upstream at the Glendale Hyperion bridge, and then it just runs through channels. And these open cellular concrete channels, dividers basically, then protect the red car, what was then, of course, the red car trolley piers from any hydrostatic loading that went across. So we knew we didn't want to take these things down. You know, that was a good thing, and we didn't want to have to get any more permits from Army Corps of Engineers or anything else. So we decided we were going to be leaving these connecting walls in place. But we were pretty free to figure out what to do with the piers, since we knew if we were going to support a bridge on them and they were solid, massive, unreinforced concrete, we were going to have to do something about them. So looked at a couple different options for what to do. This was crossing the river at a right angle and just rebuilding one pier, thought being, you know, why not just focus all the pain in one location and just rebuild one of the piers. And so these were really helpful just to kind of from a, these were just engineering concepts, you know, not aesthetic concepts, but engineering concepts for what we could do out there. We looked at options for, since these were hollow cellular dividers, we thought, well, why don't we build just inside of them, just build some nice flexible column elements and be able to use, you know, ductility of a pier and let this thing just shake inside of those connecting walls. And so we looked at that as an option as well. we looked at options like, well, what if we put it like right next to the existing bridge and took it off of the red car alignment. And so essentially what we settled on was this concept, which is what we used, which was, well, let's run it across the river and let's set it on 2 of the piers. That was a really good idea actually from the city, which was, hey, instead of putting on every pier, why don't we just hopscotch piers? And that way, we're only spending construction money on 2 piers in the river instead of, 5 piers in the river. So that made a lot of sense. The bridge spans about 430 feet, so each span is like 140 feet or so. So, not crazy long distance to do. We had, of course, the skew to deal with and stuff like that, which kind of complicated some things, but that's okay. So the piers, here's kind of a before and after, if you will. Over on the left, this is essentially all we had to work with for the structural design of the piers. This came from not the original construction drawings. This came from the Army Corps of Engineers plans for the channelization of the river. And so this is what they did to those piers when they put the channel through. And essentially what they did is they pressure grouted underneath. I didn't know they did pressure grouting back in the 1920s, but apparently they did. So they pressure grouted underneath the existing piers. We weren't sure there were piles out there even, but these drawings did show us that they are in fact pile supported. But they didn't tell us how many piles because this was a section view and no place was there any type of plan view or longitudinal view that would tell us, hey, there's 20 piles per pier or anything like that. And of course, we didn't know the depth of the piles. So very little to go on in terms of what we had out there for design. So later on, I'll get into kind of how we handled that from a calculation standpoint, which was essentially to just turn them into spread footings. So this is what we replaced it with. So I think you can imagine, a full, tall, solid concrete pier was out there. We replaced it with a, much lighter weight, open, hollow pier, which is a lot shorter. So we took all the weight off the top and we made it hollow in the middle. So we dramatically reduced the weight of these things. And even with the addition of our bridge, because it was a truss bridge, it's super lightweight in comparison to all of that concrete. So we ended up removing the total weight of the whole system by replacing it with these hollow piers. Okay, so let's see, I'll get into kind of the superstructure fabrication of the bridge. So again, steel truss bridge, very simple, hollow structural sections, nothing too fancy here. It was fabricated in Arizona at Stinger Steel. So we were able to go there and do a site visit while they were in construction of the elements. So what this is 2 separate pictures. They show the trusses laying on their sides, actually. So they build these things typically laying flat. And when we got to the site, they were just doing 2 of the trusses. So this is, it's going to be a left truss and a right truss. And they built them together and matched them on top of each other as they built them. Very cool facility, just giant buildings and, all the latest and greatest in fabrication techniques. And I guess so Stinger made a very high quality product. We actually specified the bridge to allow them a lot of geometric control. We designed it essentially. There's 3 separate trusses as you go across the river. We designed it really so that they could build the same truss in 3 different places, and then just change their floor beams to make up the geometry control. Because that's one thing we did want, for ADA requirements and everything like that. We wanted good geometry control of the deck. But as far as the trusses go, we gave them a lot of leeway in terms of what they could do. They took that leeway and they essentially threw it away. They did extremely detailed drawings and extremely good geometric control, so that as you go across that bridge, and you'll see the photos, I mean, it's exactly the shape of the floor system, and everything is offset just right, and so it's very cool. And so just some more pictures of the fabrication that went on. You know, here's a top chord splice that they had to put in, groove, weld, and grinded flat and all that. So that was nice to be able to go out there and see that, and see the kind of the quality of workmanship. And this was fun. While we were there, they were actually building they were building the segments for the orthotropic deck of the Gerald Desmond Bridge. So we were able actually to do a little trip into one of their other buildings to see that go in. So if you guys have any familiarity with the Gerald Desmond Bridge, you know, these are absolutely massive, giant segments for their orthotropic deck. I mean, I don't know how long this thing is. It goes on forever. And so, you know, we made the joke that there's probably more steel in this fin that runs along this one segment of the Gerald Desmond Bridge than there was in our entire truss that we put up across the LA River. So that was fun to see. All right, so I thought I'd share some of the site work that we had. It was a very rainy season. I don't know if you guys remember, but last spring we could not catch a break. It rained a lot, and so we were dealing with a site that had a lot of mess in it. But of course, that had to be all. We were under very strict guidance from water quality, of course, so none of the stuff could escape the site, and we were able to divert the LA River under pretty challenging circumstances, again, because there was a lot more rain than we had expected to get. So this picture, you can see we're down at river level. You can see one of the piers that we were not going to be changing is right here. Here's that connecting walls I talked about earlier. And then what you see here, this is the top of the footing, existing footing. So we chopped off all of that existing pier completely. And what they're doing here is they are drill and bonding. These were some smaller drill and bonds that we had put in the middle, and they are going to be moving over. We put in some very long drill and bond rods here on this side. And one of the nice things we were able to determine, verify, that this thing had reinforcing in it. So the footing is reinforced. It's just that the piers were not reinforced. So we were able to engage some existing reinforcing on those footings, and they stick up above the river channel, which was a nice thing because we never did anything below the river channel bottom, which made it a lot easier with Army Corps of Engineers to not have to go underneath and get underneath the concrete level of this. Made the site cleaner, less work for the contractor, made things go faster. So that ended up being pretty cool. So here we are. After we had knocked down the existing piers, we formed up new piers. And of course, since these are brand new piers, we wanted to make them look exactly like the piers that were there before from the outside. Of course, from the inside, they're very different, but from the outside, we wanted to make them look exactly the same. So here they are setting up the formwork on one of those piers. And you can see, of course, it's a cloudy day and it's raining, because it was always a cloudy day and raining. It's just amazing that it was able to get done in time with all of the rain delays we had. And then this is taken from the top of one of the existing piers that we shaved off the top of. So this pier came down something like 8 feet or something like that. And basically they had a big, essentially concrete chainsaw that they set up, and they just ran that thing right across there and just cut right through it. And then we made them refinish this up and flatten this up and put a nice topping on it slab on it so that it looks good from above. So. We made them clean up these feathered edges here too. And here you can see the water quality stuff we put in to make sure that none of that mucky water got out of the site. Okay, so once the piers were done, then it was just a matter of craning in all of the truss pieces, which not particularly easy to get a crane down there, but we were able to get that permitted and allow them to build essentially a dirt ramp to get in. The way they did it, they came off of I-5 on the I-5 off ramp, and then they went down a dirt ramp they created. They drove, literally just drove the trusses right down onto the riverbed, set up their cranes right in the river, and then set them up. So again, the bridge was 3 separate trusses. Each truss came in 2 pieces. They were able to use all of the piers, whether they were rebuilt piers or whether they were existing piers. They were able to use those as temporary supports in order to bolt all the segments together. And so as these piers showed up on site, they craned them up and bolted them together. And yeah, this gives you an idea just kind of the massiveness of all of these huge concrete elements that are right there in the middle of the river. Okay, so this basically was the end result. I'll play the video that the city of LA put together showing the bridge at nighttime. It's very dramatic at nighttime. It looks super, super cool. It's kind of lit just perfectly. Oh, what happened here? Here we go. Okay. If you're in, and I assume most of you are in Los Angeles, you've got to go out there at night and check it out and walk across it. It's just really something. Yeah, so that's the brunt of the presentation. And looks like we've got plenty of time for questions that people might have on the project. I know I'm looking, this is fun. I'm looking at the names of people that have joined. I see a lot of people that were involved in the project have joined the conversation. So we have plenty of experts out there who can answer any questions. So I'll turn it back to you, Amit.
Yeah, thank you, Doug. This was a great presentation, and I really appreciate your effort in sharing a wonderful story about this bridge rebuilding. I didn't know so much about the history of Red Car Bridge, and I really like it. As a bridge engineer, I really appreciate the work which has been done and the effort which was put in to put the existing elements and features of the bridge. So if anyone has any questions, please type in your questions in the chat box. I have a question for you, Doug. You mentioned that that the existing piers did not have any rebars. So how did you manage to get around the seismic criteria for the design?
Yeah, let me go back to that. Where did it go here? While I'm talking about it, it's probably good to have this picture up here. Yeah, so we spent a lot of time thinking about the seismicity and the loading of the bridge. And so we handled that in 2 ways. So we took it from a demand side and we took it from a capacity side. So on the demand side, I think you saw the pictures of the bridge that we used to have on these piers. And it was I think they were 8-foot tall steel plate girders, and they were supporting, again, a fully ballasted railroad system with rails, and it was double tracked through here. So, you know, the superstructure weight back in the day was just massive, right? And so from a vertical standpoint, loading, obviously we knew we were not going to have any issues at all, right? We're putting on an extremely light truss bridge. We're cutting down a lot of the weight of the bridge itself. But what we were able to do is we kind of back calculated what this thing needed to look like and what kind of piling it needed in order for it to work. And then we were able to then, from that, figure out what capacities we had, not from as-built, but, you know, just kind of from looking at sort of the historical record and, you know, how you'd have to support it back in the day. We had pile details from the adjacent Glendale Hyperion Bridge, which was a city constructed project, which did have piling details. So we knew what kind of piles that they would have used back then. But essentially it came down to the fact that we took out so much weight and we put so little weight on it that we were able to just essentially make these things work like they were spread footings. We looked at it, you can't really maybe get a sense of what this is here, but it's basically about 12 feet across at the base of this thing. So as it comes along and the seismic wants to rock these piers back and forth, we were able to look at some rocking analysis and some things like that to check bearing pressures that were not very particularly high because of the massiveness of these things. And then also be able to sort of tell kinematically that during the rocking analysis, that it was never going to reach that point where it would sort of go over the side. So, so we were very interested in, you know, making sure that this thing's going to work seismically. Most of the capacity enhancements came from simply getting rid of all of the dead load and all of the driving forces that were out there. One of the other nice things that's helpful is these are super wide, and our bridge is really just like a ribbon of steel that sits on top of these just massively wide things. So we were able to generate a lot of capacity on either side just from like a spread footing standpoint. So that's essentially how we you know, made it work seismically.
Yeah, thank you, Doug. I have a next question. Like, how is the maintenance of this bridge accomplished? Since this is a steel bridge, like, I'm sure there must be some like special maintenance required for this bridge.
Yeah. Well, I guess a couple things about that. One is, yeah, it's a steel bridge, and it needs maintenance. We used a 3-component paint system. We used really good paint. And so from a standpoint of the coating system, we used just a really good system on that. Now, Los Angeles is not a particularly corrosive place once you leave the coastal zone. And so where this bridge is, it's just not a place that gets, you know, a whole heck of a lot of corrosion. And we're out here in California, you know, we don't do road salts and that kind of thing. So I think the biggest concern we had really wasn't maintenance from a long-term corrosion standpoint, although obviously we made sure to coat it appropriately, but probably the bigger concern was tagging and things like that. So one of the things we did was, again, it's a simple steel, simple silver color. And so any tagging that gets done can just be sort of spray painted over with the silver, and they're not having to kind of match different colors or do anything crazy with that. You know, they just have to make sure they have that same color around. So it's good. A lot of our clients, which you know, we sort of push people, if they are less concerned with aesthetics, to use steel, weathering steel. And weathering steel is pretty nice for tagging purposes because you can just sort of scrape off the tag, and then what you're left with is just steel. And then over time, of course, the weathering steel just sort of takes over and it mashes back together. So yeah, we want something a little nicer than just weathering steel out here, though. So
Yeah, thank you, Doug. We are getting a lot of questions. We'll take a few more. We still have like another 5-10 minutes left. So the next question is like, how much did you cut the existing piers? How much like thickness of the existing piers were cut? And do you have to deal with any like smell or any other issues? Since this is the pedestrian bridge from the river, were there any environmental concerns?
Yeah. So we ended up cutting the piers down about, I think it's about 8 feet. I think unfortunately, it's funny how these things work out, but when we cut off these piers, we ended up cutting right through these little dog ears that were sitting here that held these old power line poles. So we ended up cutting about 8 feet off the top of them. So I want to say the top third, something like that, ended up coming down as we cut it off. And so let's see, this would have been a pier that ended up being a support, also cut down. And then this would have been just one that we just cut off. We put a lot of, we double and triple check those numbers to make sure that when we end up at the right elevation, so when they brought the bridges out, that we weren't going to like high center the thing on one of the existing piers. So I was glad that worked out. So. And then environmental for the river, yeah, huge. I mean, obviously, yeah, you don't work in the LA River without a lot of environmental concerns. Absolutely. Water quality was number one. So we had people every day, full monitoring all day long of the water quality in the LA River. We had to divert channels over. We had to make sure that we could handle a flood that might happen, a kind of a lower level flood that might come along, and go through our diversion system, and that was really one of the big challenges out there was water quality, and but the end result is really great for the environment, right? Because we've got a non-motorized facility, a way for people to reconnect with the river. It's amazing. If you stand out there, you see great blue herons, you see egrets, you see birds, and there's people fishing down here. I mean, it's really quite something. So this, as far as the, we made sure you do the right things during construction, but what we're left with, I think, is just a great environmental benefit to the river.
Yeah, thanks, Doug. I'm sure like this bridge is an iconic one. The next question is on similar lines. Like, what different permits did you need for this construction? I'm sure like there must be so many different agencies involved, like to get permits, even to enter the riverbed. So permitting process must have been really complicated.
Yeah, it was. It was, the 404, the 408s, and all that stuff. Water quality permits. We're lucky we've got a great group here. Brad Blood and his team inside of SOMAS, boy, they just know this stuff so well. I'm a structural guy, right? So I don't know all the ins and outs of that world. So I'm really lucky to have people with inside SOMAS that are just amazingly good at this sort of stuff. So we knew going in what we had to do, and we were able to, of course, there's always surprises along the way. But permitting of the project was a big thing, both from the environmental permitting side of thing, and then the flow requirements, and just making sure that we could pass the flood, and that the soffit was at the right elevation, and working with the Corps for all of those types of things as well. So yeah, lots of permitting things got done by other people than me, but yeah, it was a big effort.
Yeah, thank you, Doug. I believe, this was a great presentation. I don't see any more questions, but thank you everyone for attending this presentation. And we'll be having similar presentations like in the future. So stay tuned to SEI Los Angeles chapter. And thank you, Doug, once again, for a wonderful presentation. I really appreciate you sharing your story about this red car bridge. And thank you. Have a wonderful afternoon, everyone. Yeah.